To all my colleagues, all the audience, and all the research lovers. This is my privilege to introduce you today on this PU webinar. One of my good friend and senior colleague, Dr. Dinesh Pathak, with us. We are very fortunate as in today's COVID pandemic era. We are deadly havoc, deadly morbidity loss we are hearing from this COVID, and there is a real time is needed from the scientists and other scientific fraternity. They should come out with realistic tools, whether in terms of early diagnosis, vaccine is already with us, but also some other tools are needed for the as a PPE or the protective equipment. I'm very fortunate to introduce Dr. Dinesh Pathak. I'm summarizing his brief biodata. Dr. Dinesh Pathak is a professor. His PhD from Guru Nanak Dev University, Amritsar in 2011. He finished his postdoc during 2012 to 2015 in Czech Republic at University of Pardubice, European Union. He also worked at Queen's University, Canada during 2013. He participated in various workshops, conferences as a resource person. He delivered many lectures on the recent techniques related to his field of nanotechnology at Italy, China, USA, Spain, Poland, Germany, Czech Republic, Canada, Switzerland, and many other countries. He published more than 50 research papers in SCI indexed journals on material science. He is having more than 800 citations, and his impressive H index is 15. Reviewers, he is reviewer of more than 60 scientific journals. He had participated in 62 Lindau Nobel laureates meeting dedicated to physics in 2012. Many recognitions and awards to his credit, including Rising Star Award, International Union of Crystallography Award by Asian and Chinese Crystallography Society in Beijing City, China in 2009. I invited him and informed him for the positive collaboration, research collaboration for interdisciplinary research and the transdisciplinary research work with the applied science of Pardubice University. Much of taking more time, it is better to listen to us. So over to you, sir. Today's topic of your presentation is the Electrospun Nanofibers based filtration and protection from various viruses like COVID-19. It is my honor, privilege, and pleasure to hand over the podium to you, and we look forward the kind, successful interaction with you today. Please, over to you, sir.
Thank you, Dr. Vijay. I think I'm properly audible, and yes. Thank you for inviting me at the one of the fastest on the virtual platform of one of the fastest growing university. And I saw the profile of your university at various platforms on Facebook and on YouTube, and I was delighted to see the progress which you are doing in research, innovation, and teaching as well. And as you told that, yes, we will be happy to cooperate with your institute and organization. And I will also start initiative here from my side that we will collaborate. And obviously the fraternity with the group of people with the shared idea, shared aim that progress of mankind and progress of science, they should join hands, and then that will be better for the progress of mankind for future. And so that those things I will be initiating soon to collaborate and to work with you all people. And thank you once again, Parliament University virtual platform, that they provided me this opportunity to talk with the young minds of this university and this organization. And not taking much time, if you allow that, then I should start talking few words on the topic which I decided to discuss today. I think my PPT is still there on screen.
Yeah, yes, we are visible.
Yeah, thank you. So in between, if connection will lost, kindly message me on WhatsApp, because I connected my this system with the mobile. So yeah, thank you. So today I decided to talk with all people present here on the topic nanofiber based on TiO2 for filtration and protection from various viruses like COVID-19. So actually, nanofiber is a very specialized field belonging to nanotechnology and nanoscience, and we understand that nanoscience is helping mankind and science to progress in much better direction. And actually, the 21st century, especially 2020, witnessed a great challenge to mankind due to potential threat, and we are aware that still the threat is going on, and we were forced to live in isolation from last year, and because of this corona virus, and this has still much potential, much risk toward the mankind. And although the vaccine is available and people are being vaccinated time to time now, but prevention, we understand that prevention is better than cure. So preventing vaccine, many medical prevention from vaccine we can have by this by increasing our immunity, and to keep boost our immune system. We have various methods, but some methods are there also to prevent the this virus, to stop the virus, and that is masking. And we understand that the virus size is quite small. People are saying that the virus size is around 100 nanometer. So ordinary mask may not help for this purpose. And that is why if we see various researchers, those who are doing research in this field, if they explore the idea on the internet, they will see that the people are talking about nanofibers. So what are nanofibers actually? This research is not new. The fibers are helping for mankind and science in various other applications like water filtration and other, so many applications of nanofibers are available there. But we can also prevent this COVID-19 novel coronavirus with the help of nanofiber masks. And the field nanofiber is not new. It started from many years ago, and because of high porosity. If I will show you the next slide here, this is the same image of the nanofiber. Here we see that they are actually porous materials, and by controlling the pore size, we can have various applications. So, for example, in the top in this slide, we see here if the porosity is less than 100 nanometer, we define them as nanofibers. And by controlling during synthesis, we understand that we can control the structure during synthesis. Chemistry people and material scientists, they know that how to control the structure. So if we can control the porosity within 100 nanometer, these materials can have various applications, and one of the application is that preventing novel coronavirus. So coming to the previous slide, I must say to you that nanofiber industry is not new to the world, and the market has already reached around $500 million. And I was working in Czech Republic for some time, and in Europe there are even in Czech Republic, which is a very small country, there were around 20 to 30 nanofiber based industries. So now coming to the next slide, for the beginners, those who wish to do research in this field, I must define what are nanofiber. So they have fiber-like structure at nanoscale. If we see the fibers by naked eye, then we see they are ordinary material. But if we see the fibers under the electron microscope or transmission electron microscope, we see that they have structure like this. And so they have diameter around in nanometer range. They can have porosity in nanometer range. They can be generated from various polymers and organic materials. So if you see here on the top, if we sandwich nanofibers inside the different ordinary fabrics, we can have nanofiber masks. So they have potential to stop the novel coronavirus. So there are many applications of nanofibers, like in tissue engineering, in drug delivery, in cosmetic, in filtration, in protective clothing, even the medical dressings we can have, because medical dressing we need of that kind that air can pass through up to your wound, but the medicine or the liquid medicine which is placed inside that for healing purpose, that should not come out. So we have various applications of nanofiber in medical industry, in sensor, in electrical conductor, for optical applications. Now question is that why nanofibers? So because I said already that they have very small pores. Porosity is very fine, very less than 100 nanometers. So if we, for example, if we stop the, if we wish to filter water, so if we wish to stop the lead or arsenic or the toxic element, because they have bigger size, so that type of porosity we can porous material we can synthesize. And similarly, we can have water filtration. They have many application in distillation, like in chlorination, deionization, etc. So means by controlling the porosity, we can have various applications. That is why nanofiber are the center for attraction for people working in the field of nanotechnology. So nanofibers can be made from organic materials or polymers. Sometimes inorganic is also blended with the organic, because the organic material they have less strength, and to make them sustainable for various applications, we can mix with those material with some inorganics. So for the beginners researcher, the people, those who are beginner in the nanotechnology, they must understand that because nanofiber have very high surface to volume ratio, they have tunable property. Now, what is the meaning of tunable property? Tunable properties means if you wish to filter water, you can synthesize porosity of that kind of porosity you can achieve, and then you can do that. Similarly, if we wish to stop the viruses, then we can make them tunable according to that properties. For battery separator means the nanofibers have very high surface to volume ratio. They have tunable porosity. According to our application, we can synthesize. In further slides, I will discuss that how to tune the porosity. They are flexible. They are lightweight. This is very important, because there are many other materials which are available there in industry, but they have heavy weight. So nanofibers are lightweight, and they have low cost, less energy consumption, etc. So this make them center for attraction for people working in the field of nanotechnology. So now, what can be the methods to produce nanofibers? There are various methods like drying or electrospinning, self-assembly, template-based synthesis, and then force spinning as well. So I am also beginner in this field. I published many papers in the field of nanotechnology, photovoltaics, and hybrid solar cells, etc. But this work we started last year with one of my research student here. So we fabricated some of the nanofibers by method of electrospinning. So what is electrospinning? What we do is we have machine like this, instrument like this. This eSpin nanotech company, which make these electrospinning machines. This is Indian actually. This is established by one of the doctorate fellow who did his PhD from IIT Kanpur, and later he, with a startup, he started this eSpin nanotech company. This instrument is dedicated to the particular phenomenon named as electrospinning. I'm happy to share with you that India is very much progressing in the field of producing nanofibers and industrializing them. In even this company, eSpin, they launched this mask. The mask name is Swasa actually. You can buy this in around 100 to 200 rupees. And even you can see Prime Minister and various ministers of the central government department wearing these masks to prevent the coronavirus. So now I must tell to the beginners researcher that what is electrospinning. So electrospinning is a method actually where we apply some potential to thread out some fibers and to make the fiber-like structure. We have a solution.
Hello.
Uh, we have a solution of the material of which we are interested to make nanofibers, and we put that in this kind of syringe here, and we apply some potential over here, and the opposite potential over the collector, and a thread-like structure that can be collected over the drum. And so here in this in the machine, you can also see this is first is systematic diagram only. An actual machine is like this. So means by controlling the potential here, we can make thread those thread of the diameter of those fibers thinner or thicker. Similarly, we can change the distance from syringe to drum here. We can change the speed of the drum here, and we can change the potential even. And then with this technique, we can modify the we can control porosity. Actually, that is why we say tunable nanofiber means the porosity and the diameter that can be changed for the applications or for the possible application which we desire. Nanofibers have various applications. This we already discussed, that they have applications in tissue engineering, drug delivery, cancer diagnosis, lithium batteries, and optical sensor filtration, water filtration or air filtration or wound testing, etc. So we put actually we made a blend of organic material with the titanium dioxide here. Why we added titanium dioxide? This I already explained, that because to make the good strength, because to have some application of some to have some application of the produced material, that should be mechanically sustainable. So that is why titanium oxide was blended here with the polymer. So I will not go much in detail that what are the properties of titanium oxide. This is a separate. So what we did is we made a blend of TTIP. TTIP is actually precursor of titanium dioxide, and PVP. This is a polymer. We made two solutions. PVP that was mixed with ethanol, and TTIP that was mixed with ethanol and acetic acid, and then both solutions were mixed together, and then they were stirred for 45 minutes, and then they were filled in this syringe. Actually, this nanofiber electrospinning machine is not always like this. There are many other possibilities depending upon the instrument. So sometimes we fill the solution in a drum, and we have fiber collection on the other side. But the simplest way is putting the solution in syringe and then collecting the fibers by electrospinning. Electrospinning means we apply opposite potential, and then because charging of solution, we can collect the fiber-like structure over here. The very much important thing we should understand here is that by changing the distance from syringe to screen, by changing the potential, or by changing the solution pH concentration, or maybe by changing the speed of the drum means over where the fibers are being collected, we can change the porosity and diameter, and hence the applications, obviously, because applications depends upon the porosity of these porous materials. So what we did is we made these two solutions, and then we tried to find. This is just a table showing that how we mixed the how much quantity we mixed. We varied the percentage of actually PVP and this T that is the precursor of titanium dioxide. Then finally we stirred this in the beaker for around 1 hour, and then this is just means the values for experiment, that but the initial experiment which we performed. So we put 7% weight of polymer, voltage we applied around 11,000 volts, rotations we made around 350. This can be varied actually, but we just fixed to have porosity of desired porosity for various applications. So distance we fixed around 18 centimeter. Distance from syringe to drum. From syringe, the solution is the that is exit point of solution, and that screen is the collection point. So this is just the closed view. This is a syringe in which we can put the solution, and we can collect the fibers over here. Fibers are forced here from syringe to this drum because of the opposite potentials which was applied from outside. So finally, what we found these type of structure which are very wonderful for a person who is do not belong to science or do not belong to material science. For him, these things are nothing, but those who work in material science or in nanotechnology, for them these structure are very fascinating, because see here, you can see the porosity and diameter that is buried. So this is not a new thing, that porosity and diameter is varied. That this is obvious, that porosity will be varied. But yes, this is fascinating and interesting that we were able to have porous materials. So now this porous, why we need porous material? This I already explained. If we are interested to filter water, we can have a porosity according to that, because that water should only be allowed to enter, and other things they can be stopped. And similarly, if we are interested to filter some viruses like Ebola or maybe Corona or maybe Hanta viruses, or various viruses are being outbreaked nowadays from time to time. So these material when sandwiched in different fabrics, they can help to us prevent the viruses or other things. That means filtration, air filtration, water filtration, or the virus filtration that can be done. So this is just a table showing that how much porosity we obtained. See here in the second column, we can see that we were able to have porosity 4 nanometer, 2 nanometer, and 1 nanometer, which is very excellent, for especially this 4 nanometer. If people are not much aware about the coronavirus size, but as far as that is predicted, the size is around 100 nanometer. Some reports they say that the size is around 110 nanometer. So if we have masked with the porosity around 4 nanometer to 10 nanometer, or even more up to 20 nanometer, we can stop the coronavirus and various other things. So if we are interested to filter air or water or maybe viruses or other things, filtration industry can use these fibers with very much possible advantages. So just we also did the X-ray diffraction, which is not important here. Actually, X-ray diffraction is done to have structural analysis. If we are doing the filtration of this coronavirus or water, X-ray diffraction has nothing more important, because we are not interested in structure. But if we are making these fibers applicable for some optoelectronic industry, obviously the structure matter, because if there is some arrangement, the properties like band gap or structure or band gap or other electrical properties, they varies. So that is why we did it, and we found that they were amorphous in nature, because we didn't find some diffraction peaks here. And so this is not much important when we are talking about the filtration. So we also did VET analysis, which is dedicated for this uh, porosity analysis. Actually, what we did is here, with the help of SEM, the porosity is not exact, because we can have just idea from histograms, and by scaling, by see the scale here. But actual analysis is done by VET if we are interested to have porosity and diameter. What we do is we put those who belong to material science, they must be aware. But for other, I must say that what is VET analysis? We put that material in some chamber, and the gas is absorbed in the material, and obviously where there will be pores, there will be no absorption. Then there is desorption later, and we by seeing the analyzing the adsorption desorption curve, we can have idea about the porosity. So this is the porosity which we found with the help of porosity and surface area and pore volume, which we found with the help of BET analysis, which is actually accurate analysis. The accurate analysis is done always of porosity is always done by BET. So we found here again that the porosity ranges from 1 to 10 nanometer, which is quite interesting because if we have masking, uh, sandwiching of these nanofibers, sandwiching of nanofibers, then inside the cloths or whatever which we are making this mask. So obviously the viruses which have size more than 10 nanometer, that will not be inhaled by our body from mouth or nose as like that. So means this porosity can be varied. That we already understood. This can be varied with by changing the conditions of by optimizing the conditions during experimentation. But we found that the porosity is quite encouraging to stop the spread of this coronavirus, especially which has size. Medical scientists, they expected the size of this virus, novel coronavirus, around 100 nanometer. So this is just the size which we see for the various other means expected size, diameter, and this we already discussed. We also try to filter water with the help of these membranes. We can say membrane, these nanofibers, and we found that we were successfully able to filter water. Close view you can see here. But we were not able to stop the lead and arsenic. Actually, we just were able to stop the only this microparticle with the help of this. And we are continuing this work further. And let's see how it will go further. But yes, they are good. The fibers are good material for the filtration of water as well. Now see, from this table we can see that the size of toxic element, they have around size from this to this range. Beta molecule have this from range is written here. So novel coronavirus and few other viruses like
Hello, Dr. Dinesh. Hello, Dr. Dinesh. Hello.
सर ये आया है
कौन सा आपने चेक कर लिया है?
नहीं नहीं अभी तक ऊपर नहीं आया है, पर यहाँ पे CR40 ऐसा कुछ लिखा नहीं है, मेन गेट की कोई एंट्री या इनको कुछ हुआ नहीं है, तो हम कैसे एक्सेप्ट कर लेते हैं?
उसको बोलो इसमें CR40 लिखो।
हाँ, क्योंकि इस पे हम साइन कैसे करेंगे?
CR40 लिखो और HPTLC से रिलेटेड लिखो, एक्सेसरीज एसोसिएटेड विद HPTLC ऐसा लिखो।
हाँ, और ये
हेलो हेलो जितेन सर, हेलो हेलो सर, आपका इंटरनेट वो हो गया क्या? आपका प्रेजेंट चल रहा है? अच्छा, प्लीज कंटिन्यू, प्लीज कंटिन्यू। हाँ हाँ, इसीलिए वो मैं बोला, आप इंटरनेट का कनेक्टिविटी देखिए थोड़ा, ठीक है। हाँ। अरे सर, वो डिस्कनेक्ट हो गए, वो पाठक सर। बोला तो है, लेकिन ये अभी
Dr. Vijay. I am presently in the hilly state Himachal, so there are sometimes issues like this. So the connection was lost. So now coming to again the discussion, that point that I was discussing, that how the porosity can be controlled. So I was discussing that when we have solution placed here in the syringe, and when we change the properties of the fluid, or the distance from the syringe to that collector, or maybe the potential or the rotation of these diameter, the porosity can be optimized. And obviously this was our aim to, because different kind of porosities will give different applications. So we successfully synthesized the nanofiber with different porosities. This can further be optimized. We can change further the diameter by controlling the various parameters, and hence that material can have applications ranging from water filtration, air filtration. I will give you one example here, that for example, if we are interested to filter the virus, for example, COVID-19, then we should have porosity that this lesser than the size of that virus. And medical people, medical science people, they are saying that this material has porosity around this virus has a size around 100 nanometer. So if we will have porosity less than that, then we can stop the virus spread. So this is what we got. We got the porosity around 1 to 10 nanometer, and that can further be optimized. We also did X-ray diffraction. This is not much important when we are talking about the filtration, air filtration or water filtration. But if we are interested in making some optoelectronic device, obviously structure matter, and structure can be determined with the help of X-ray diffraction. Another best method to have idea of porosity is BET analysis, where what we do is we put the material, the synthesized material, in a tube and in a vessel, and then we allow the gas to be absorbed on the surface, and then desorption later, and then with the help of that, porosity can be estimated. So this is a table of the porosity and surface area with the help of BET, and we found that the porosity ranges for our material, which we synthesized, is from 1 to 10 nanometer, which is quite excellent. Again, giving the example is that the size of coronavirus and other viruses, they ranges from 50 to 150 nanometer, so they can be stopped by using this material. We also tried to filter water with the help of these membranes. Yes, we can say these material as membranes, and we found that we were successful in stopping the pollutant and some other things with the help of these membrane and nanofibers. So this is the table which I must show you, that how these fibers, porous materials especially, they can be. There are many other porous material available in industry, but they are inorganic based, so they may have heavy weight. The fibers have light weight, and hence they are very much interest. So if you will see the table here, you can see in the last row that the fiber, that the virus diameter, the various virus diameter, they are expected to have size, like from Ebola to COVID to SARS, they are expected to have size from 50 to 140 nanometer. So if we can synthesize, yes, we can synthesize, and these nanofiber according to that porosity, and so we can stop the spread of these viruses. Now, what is the conclusion? Conclusion is that one thing is that, is the nanofiber industry new to the world, or the market is new? No. If you will see on the internet, there are around thousands or more than that industries worldwide which is producing and industrializing the nanofibers for various applications. So what is new? The new thing is that we should make the methods low cost for the industrialization, for the industry need, and we should explore many more material in the form of nanofibers, so that various other applications they can be realized. So these are the challenges for future, that for filtration mechanism we should understand the filtration mechanism. We should make them mechanically more sustainable, so that they can withstand for more and much time. And then commercialization, which is already being done by various industries worldwide. And the one thing is that along with many other applications like battery separators, in optoelectronic industries, in solar cells, or maybe in water filtration, the these fibers are also have potential. Fiber looks to have also to have potential to stop the spread of this virus, which has made life of bee people terrible from last 1 year. So you can also buy this mask in market. But many, not many, but one of the company established this by eSpin. They launched the mask, nano fiber based mask. You can see the various ministers, even Prime Minister, wearing masks. That masks. The name is Swasa. So means this field is quite interesting, and to make life better, to protect the mankind from these viruses as well. The nanofiber looks to have good potential. So now, if you have some questions, we can discuss some question. And I'm also beginner in this field. I am trying to understand the mechanisms and fiber science, like many of you. But if some people have some question, they can discuss, and if not now, I will be happy to answer your queries later even. And if some people wish to join research in this field, I with Dr. Vijay has planned some project, because he belonged to medical science and I belong to physics, and so I decided to join hand with Dr. Vijay and other colleagues of Parallel University. And so if you have some questions related to this field, or that if you wish to join even research in this field, I will be happy to answer your queries later even. Dr. Vijay.
Dr. Dinesh, I am very happy and giving 3 claps for your
Thank
wonderful
you,
and impressive lecture. My one concern is that for PP mask preparation, what will be its material cost? Because this type of discussion was happened with IIT fellows also, the triple layered mask and all. What is the cost size you look forward for that development of any mask? Is it user friendly, cost effective?
Yeah, it is not much costly, because the preparation and making nanofibers at very large scale is not much costly. Even if this instrument means that this syringe-based instrument that may not produce very large quantity nanofibers in short time, but because here from the syringe we force only one thread coming at single time. But there are many other modified version of this electrospinning, where too much fibers can be forced to allowed to have to come from the liquid and to deposit on the drum. So means yes, this field is not means the issue is not cost. Cost is very less. Even
I'm
in
asking, what is the probable cost? Just rough estimate, 200, 500?
yeah, this mask you can buy in around 100 rupees, 100 to 200 rupees in market.
So what my suggestion is that we are dealing with many startup programs and all this.
Yeah.
At least to set up a small unit, because every ideas can be comes into the reality. Okay. So why don't jointly we can start, or at least 100, 200 or 500 mask preparation, and from Mudra and other Yojana we can take the fund. What will be the probable budget cost for this?
Okay. We are asking that what is how much this machine costs? This machine costs around, in less than 10 lakh. in less than 10 lakh, you can have all these setups.
So overall, suppose we are joint venture as we are starting a mask preparation setup here. So what will be the minimum cost so that we can ask from some startup loan or we can ask for buy and because
Yeah,
it
means
is wonderful.
I think, yeah, I think we only need to buy this machine to make nanofibers, and then further making a mask is that is not costly. We need
Okay.
just like clothing type units, and we can sandwich the nanofibers in the clothing type. We need only to make the sandwich like means so that is not much costly.
Okay.
Yeah.
Second thing is that, sir, have you patented it? It is a very bright and impressive technology. Have you patent? You are applying for patent. This is totally your concept or? Uh,
No, no, this is not my concept. This is also in
ach-
industry. This is already in industry,
okay,
and
because
that these e-spin people, they are already producing masks and selling them.
yeah,
But we can think further to modify the structure and for the various application, and then we can think further of patenting everything.
because you under
I, yeah, already these things are in market, but we can
because
think further first to modify the structure, to explore more materials, and to then we can see some other applications. Then we can think.
second thing, sir, because you understand that COVID is still remain to be continued. At least is havoc will remain this year also. So as far as the mask preparation is concerned, you can develop some video how exactly the things are happening, the things are getting
Yeah, yeah,
coated.
yeah, yeah. Yeah,
Means you nicely
that I
explained.
can.
Yeah, but
Yeah,
any YouTube video is there now, we will highlight this after your
yeah.
presentation.
That we can do,
Yeah,
and then I will share with you.
because we are having engineering department also, Ayurveda department. So could you think that if physics and nanomaterial point of view, is it okay? But some copper nanoparticle or some any herbal formulation can be coated it on.
Yeah, yeah,
Means
yeah,
let it every department, whether pharmacy, Ayurveda, to come and explore. As long
yeah, yeah.
as it is giving positive outcome, nothing is wrong.
Yeah, that we can plan. Yeah.
Suppose your mask is costing 120 or 150, and by adding homeopathic or Ayurveda tool, it is going 20-30 rupees more. Let it be. Let something good come out, because
Yeah, yeah,
200-500 rupees we are
yeah,
wasting on petrol just for one site and all this. So in today's
yeah, yeah,
era, price is not concern as far as the quality is maintained and it will be usable. So I think this is really wonderful lecture. I want we should give some
Thank you.
prototype look to this one. Okay,
Yeah,
and
yeah, yeah.
I
That we can do.
request you. Yeah,
We can explore more materials, more porosity issues,
yeah,
and then we can further think. Means this field is quite interesting, that nanofibers and their applications.
yeah.
And even
And
I worked for around 6 months in Czech Republic in that industry based upon nanofiber production.
yeah.
So yes, we can think of that.
And Dr. Dinesh, another point I want to ask you that being as a Paru University, we are very resourceful. Means resourceful in terms of network of industrialists, entrepreneurs. So my request to you, you may please suggest what is your expectation from us, because you have idea and we can ready to help in possible way in collaboration. So you may please
Yeah,
suggest so that I can note it down and we can come out, because
yeah, yeah. Means
it should not be any activity just your talk is over and we are
yeah,
giving three claps. It
yeah,
should
yeah,
be continued with some vision, at least some roadmap and all. So
yeah,
you
yeah.
may
Means
please please suggest
one
your
thing is that
expectation.
one thing is that we can write joint projects, and we can fetch the funding from government organization and industry as well. Especially we should look for the industry, because those projects are more technologically important, and they have potential to address the need of the hour. Some government-based projects are outdated, even some, not all, but some. So, but we should look the funding from the industry, and we should cooperate with the industry. We should encourage young minds to join those projects and to have training, so that the idea of Atmanirbhar Bharat that can be realized. And one more thing is that I should want to highlight here is that we should try to we should try to force India as science and technology based economy. because only then the idea will be realized. We should work in a way that we should not be bringing the things from China. That is okay. We are doing that, and for more time even we need to do that. But for future, we should be able to export the things, science and hence technology based things. So we can do means we can join the hand. You belong to medical science and we are from chemistry or something, physics, material science. So
All we
that
are in
will,
the same field. Nowadays, interdisciplinary, we are all
yeah,
interdisciplinary.
that I
As
understand.
now, you
That
are
I
my
understand.
last question to message to the community. You are in one line or in specific manner.
Yeah,
Expectation.
my one message to communities. I work also along with the in research and guiding PhD students or MPhil students. I also work for science popularization in schools and colleges, etc. So my request to the young mind is that let us bring better people in science, and so that they can cultivate technology. For example, Gulf has oil. Some people may have diamond and gold, but some countries do not have these things. For example, Korea, Israel, they cultivated science, and they cultivated technology, and they become the world leader in science and hence technology. So India, it is a time for India. We are doing good in software. We are doing good in textile, but we should also do good things in science, and hence so that we can have this technology. We can cultivate the technology, and hence we can be able to have science and technology based economy. Yeah.
Okay. Okay. Thank you, Dr. Dinesh, for sparing time with us and you for wonderful and valuable insights. So I congratulate from the behalf of Parallel City Center of Research and Development for this wonderful talk. We will remain in touch, and as per your vision and our research interest, we will definitely collaborate not only with the nanofiber, the domain of your interest, but with many more outcomes. And I look forward your longer stay with you, directly, indirectly related with the research activity.
Yeah. Thank you.
So
Thank you once again.
thank you to you all. Okay.
Thank you.
So sir, yeah.
Thank
So
you.
we can with this concluding vote of thanks, I conclude this meeting. My sincere thanks to PU webinar group also and event department for wonderful organization of this event. Jiten sir, Dr. Jiten sir. Hello. Okay. So so thank you.